Hello viewers, in today's session we are going to discuss another important problem from domain of functions, and in this class we are going to find out the domain of this function f of x, that is equal to cos inverse, and here we have a logarithm of x minus square root of 2 to the base 2 minus half, right? So let us see how we can find out the domain of this function using the concept of principal value branch of inverse cosine function, right? So let us start. So here let us take this term as theta. So we can now take theta is equal to a logarithm of x minus square root of 2 to the base 2 minus half, so that this function it assumes the form cos inverse theta. Now from inverse trigonometric functions we know that cosine inverse theta, it belongs to this closed interval 0 to pi, that is the range of cos inverse theta is from 0 to pi, provided this theta it belongs to this interval minus 1 to 1, that is theta is greater than or equal to minus 1 but less than or equal to plus 1. So let us make use of this inequality, right? So here we have this expression equal to theta. So let us substitute this value of theta in this inequality. So we have now minus 1. Here we have log of uh, x minus root 2 to the base 2 minus half, and here we have 1, that is plus 1, right? So let us solve this inequality. So here we have minus half. So let us add half to this inequality throughout. So we have minus 1 plus half, and here we have log x minus root 2 to the base 2, and here half and minus half get cancelled, and here we have 1 plus half. So minus 1 plus half is minus half, and here we have log x minus root 2, and here we have 2 base 2, and this is 3 over 2, right? So now to move further, here we have log function, that is log of x minus root 2 to the base 2, and here the base 2 is greater than 1, and we know that from the theory of functions, that is the function log of say x to the base a, where this a is greater than 1, then this function is an increasing function, right? So here what we will do, we'll get rid of this log function by raising these three quantities to the power of 2, right? So raising these three quantities to the power of 2, we have 2 raised to minus half, right? And here we have 2 raised to a log of x minus root 2 to the base 2, and here we have 2 raised to 3 over 2. So now let us see this expression. Now this expression is of this form, that is a raised to log of say p to the base a. Then we know that the value of this expression is equal to p. So we have now 2 raised to minus half is 1 over square root of 2, and here we have simply x minus root 2, because the value of a is 2, and the value of p is x minus square root of 2, and here 2 raised to 3 over 2 is 2 root 2, because we can write 2 raised to 3 over 2 as 2 raised to 1 plus half, that is 2 raised to 1, and 2 raised to half, that is 2 root 2. So now we have this inequality. So let us add plus square root of 2. So adding root 2 throughout we have 1 over root 2 plus root 2, and here we have x, simply x, because root 2 and minus root 2 get cancelled, and here we have 2 root 2 plus root 2. So now simplifying this, we have 1 plus 2 over root 2. Here we have x, and here we have 1 root 2. So this is 2 plus 1, 3 root 2. And this is 3 over root 2. And this is x, and here we have 3 root 2. So now here rationalizing the denominator, we have 3 root 2 over 2, and here we have x and 3 root 2. So the domain of this function is given by this inequality, that is x belonging to this interval 3 root 2 over 2 comma 3 root 2, and remember here both the extreme points are also included, right? So the valid values of x for which this function f of x is defined is given by this closed interval 3 root 2 over 2 comma 3 times square root of 2. So this is how, by making use of the concept of inverse trigonometric functions and this inequality, we can easily find out the domain of functions of these kinds.